Good morning, one and all. From myself, Endur Gaurav from EC Department, Vignan Snirla. Today we'll discuss the inverse jet transform topic. Generally, the inverse jet transforms will be done in the four methods. The first one is the inverse jet transform. Inverse jet transform will be done in the four methods. First one is long division method. And the second one is the residue method. Third one is the partial fractions method. And the fourth one is convolution method. In the long division method, we see it by the example directly. That is, take the jet transform x of z is equal to z square minus 2z. The given ROC is mod z greater than 1. Whenever we say that the mod z is greater than 1 as our ROC, then we should take the sequence as our right-sided sequence. For that, the correspondingly, we should differentiate the forms of the numerator and denominator in the powers of in the positive powers of z only. That is, as it is like this. Here z square z will be in positive powers, z cube z power minus 2 z will be in positive powers. When they ask to perform the long division method for the mod z greater than 1, then perform the division for the positive powers of the z. That is, whatever the given form. If it is given in the negative forms also, convert them into the positive forms of the z, then perform the long division. That is given by, I am taking the numerator as z square minus 2z as it is. Next, the denominator as z cube minus 3z square plus 4z plus 1. Now to cancel this z square, what we should do is, we should multiply a z power minus 1 to this z cube, then we'll get z square. That's why I'm taking the coefficient as z inverse. When we take the coefficient as z inverse, multiply this coefficient to this divisor. That means z inverse into z cube is z power minus z power 2 minus 3z square into z power minus 1. It is z plus 4z into z inverse is 4 plus 1 into z inverse, it is z inverse. That will be the terms. Then take the opposite sign set here. Then cancel these two. This 3z minus 2z is z minus 4 minus z inverse. Like this. Now we should cancel the corresponding z inverse. To cancel that particular z inverse, what is the term that we need to take? That we need to cancel the 5z. That's why the coefficient as 5. Here z cube. Z cube will be multiplied with z power minus 2. Then we'll get 5z here. Next 5z power minus 2 will be multiplied with minus 3z square. That's why minus 5 3 is 15. Z power minus 2, z power minus 3. It is constant value only. Next 5 into 4, 20 z inverse plus 5 z power minus 2. Take the opposite signs, negative, positive, negative, negative. These two gets cancelled. Plus 15 minus 4, it is 11. Minus 20 minus 1, minus 21 z inverse minus 5 z power minus 2. Now the constant value as, now the value as 11. To cancel that particular 11, we should multiply the 11 z power minus 3. Then we'll get 11 at here. Next 11 into minus 3 is minus 33. Z power minus 3 into z square is z inverse. Next 11 into 4 is 44. 44 z power minus 3 into z is z power minus 2. plus 11 z power minus 3. Next, minus, positive, negative, negative. These two gets cancelled. Plus 33, 21. It's 1. 11 z inverse minus 49 z power minus 2 minus 11 z power minus 3. Like that. Z power minus 2. Next, similarly, another, for cancellation of this 12 z power minus 1, take the 12 z power minus 4, like this. This 12 z power minus 4 will be multiplied with z cube, will get 12 z inverse, and 12 z power minus 4 will be multiplied with minus 3, that's 36 z power minus 2, 12 4 48 z power minus 3 plus 12 z power minus 4. Now these two gets cancelled. Then 3, 1. 13 z power minus 2. Next, 9, 5. 59 z power minus 3 minus 12 z power minus 4. This is the series. Therefore, this x of z will be written as, the given x of z is z square minus 2z by z cube minus 3z square plus 4z plus 1 will be written as our first the coefficient, that z inverse plus 5z power minus 2 plus 11z power minus 3 plus 12z power minus 4 plus and so on. After that, this remainder by the divisor. That's why this is a continuous series. Therefore, this particular x of z will be written as the first the coefficient followed by the remainder by the divisor. But this is an infinite series. That's why no need of considering that remainder by the divisor. Hence, this is the given x of z. Now the x of z will appear in the positive powers of z, will be in positive powers of z, Therefore, x of z will be taken as summation n varies from 0 to infinity, x of n z power minus n, like that. Hence, that x of n will be a series from 0 to infinity. That's a right-sided sequence. Right-sided sequence. When we put the n is equal to 0, it's a constant, but constant is not there. But when we put the n is equal to 1, it is x of 0, this value is 0 because the constant is not there. Then x of 1 z inverse plus x of 2 z power minus 2 plus x of 3 z power minus 3 plus x of 4 z power minus 4 and so on. Here z inverse, but here the constant value as 1. That's why x of 1 is 1. When we compare this x of 2 z power minus 2 here, therefore x of 2 will be 5. When we compare it here, x of 3 will be 11, x of 4 will be the 12. That's why x of n is equal to x of 0, n is equal to 0. That's n is equal to 1, its value as 1, n is equal to 2, its value as 5, n is equal to 3, its value as 11, n is equal to 4, its value as 12, and so on. That is the corresponding x of n, where n will be in the right sided. That's the for the positive powers of the, with the ROC as mod z greater than 1, the n will be in the positive. If we want to calculate the same problem with the mod z less than 1, then the reverse process will be taken. The n will be in the negative. That we'll see next problem, in the next problem. We have seen for the ROC as mod z greater than 1. Now we'll take the case 2, with the ROC as mod z less than 1. Whenever the mod z is less than 1, we should take the reverse process. That division will be taken with the lower powers first, that is minus 2z first plus z square and 1 plus 4z minus 3z square plus z cube. Let's rearrange that particular numerator and denominator like this. First take the lesser powers. Here the lesser power as minus 2z, that's why that one as first. Next plus z square. Here lesser powers is the constant term, that's why 1 plus 4z minus 3z square plus z cube. That expression is not changed, but we are just changing the order, putting the lesser powers at the first and later the larger powers. Now first we need to cancel this minus 2z. Will be multiplied with 1 head here, that's minus 2z is a coefficient. Minus 2z into 1 will be the minus 2z. Next minus 2z into 4z, it is minus 8z square. Next minus 2 into minus 3, it is plus 6z cube. Next minus 2 into 1, that's minus 2z power 4. Then positive at here also positive, negative, positive. These two gets cancelled. Then plus plus, it's 9z square minus 6. Then multiply the 9z square into 1. 9z square. 9 into 4, this is the 36. 36z cube. Next minus 27 z power 4 plus 9 z power 5. This negative, negative, positive, negative. That is minus 36 minus 6. It is minus 42 z cube plus 29 z power 4 minus 9 z power 5. Here minus 42 z cube. Minus 9 minus 42 z cube. That's why this minus 42 z cube will get cancelled at here. Then this will be the coefficients. Like that. Therefore, similarly the x of z will be written like this. In place of the z square minus 2z by z cube minus 3z square plus 4z plus 1. For the ROC as mod z less than 1. Then it will be written as our coefficient minus 2z plus 9z square plus minus 42z cube plus and so on. Like this. Again here the positive powers of z now, therefore the n will be in negative, minus 1, n will as minus 2, n will be minus 3. Therefore x of n will be written as, at the n is equal to 0, its value as 0 at here, n is equal to minus 1, its value as minus 2, n is equal to minus 2, its value as 9, n is equal to minus 3, its value as minus 42. And so on. It will be in this side the negative. That's why it is a non-causal sequence where the long division will be performed for the mod z less than 1. Here n will be in negative, n is negative, but x of z will be in positive powers of z. Positive powers of z. That's positive powers of z.